My name is Sissy Verspeek. I'm from Amsterdam, from the Netherlands, and well, I'm here today to talk about LCAs. That is my specialty, focused on natural and ecological building materials. First of all, I would like to know from you who you are and why are you here, and what is interesting for you about LCAs, and then I mean also the environmental impact. I realized that the focus in Turkey is more on energy, and so we're going to see how we can connect that with LCAs.
Kaleli from Özyeğin University, Center for Energy, Economy and Environment. I'm an architect and sustainability consultant. So we usually work on sustainability consultancy projects on sustainability in built environment and Horizon EU projects working on this subject. So we have consultancy projects on Pakistan and Turkey. So it is a little bit challenging to work on LCA and energy point of view on those climates.
My name is Hakan Baş. I am an academician working on ecological buildings and the nature building materials and generally and sustainable buildings at İzmir Katip Çelebi University.
It's Ahmet from Istanbul. I work for sustainability as a sustainable consultant for buildings, but mostly on energy aspect, energy efficiency, and I give also lectures at the university about ecological architecture.
Okay. Yep.
I'm also doing PhD on energy side of buildings.
Hello everyone, I'm Ömer Saatçıoğlu. I work in Istanbul Gelişim University and I worked on straw bale construction techniques and ecological architecture, and I have some 3 patented inventions about the straw bale and how we can use it more efficiently in the Turkish conditions. And on the other hand, I'm also trying to adapt the energy systems within the wall and breathing wall systems, etc. So I think that's
all right. Thank you.
Fred van den Burg from Agrodome, colleague of Sissy, also working on LCAs.
I wanted to start with the basics just a little bit. I'm wondering if how familiar you are with LCAs, with the life cycle analysis, and maybe also do you have any knowledge about LCAs? Have you worked with them more or less? So life cycle analysis for maybe products or for buildings. It's life cycle analysis, which gives an impression about the footprint, not just about CO2, but the whole production and a lot more environmental impact categories.
Well, maybe I can make the start about the life cycle analysis. So it's so important to the energy cycle, especially when you are harvesting the material, and then we need to bring that harvest material to the factory, and then we are spending lots of energy to produce it, and then afterwards we bring it to the construction site and we make the construction, which is another energy consumption issue, and then afterwards we use that building and the materials, and there is the consumption. We need to heat the building, cool the building, air ventilation as a whole, all throughout the lifetime of the building and the materials that we are using it. And then of course there is the recycle and demolishment and reusing of the materials that we need to count into the system. And of course there is the transportation energy. So if you are exporting a building material from Norway to Turkey, for example, it can be a sustainable building or material like timber, but it is not becoming a sustainable building material then if you make it in Turkey and build it with Turkey maybe. So the same building, maybe the same material, the same details, but the conclusion may be different because of the you are using or not using the local material. Okay, so I think this is the a short
Thank you. Yes.
Coverage. Maybe we can get in detail about it.
Yeah.
So yes, life cycle assessment is very important actually, because sometimes we think that like we exclude concrete and we say very bad things about concrete, but even sometimes concrete can be a more sustainable material in terms of if you consider the whole life cycle compared to a natural material. Of course, natural material is always preferable, but when we consider the production phase, even sometimes we think about clay, a kind of a tile, for example. A tile can be can have more embodied energy and more embodied carbon when you compare to a synthetic material. So it's important to consider the production phase of these materials and then think the whole life cycle. You know, in the certification systems now, green building certifications, the life cycle assessment is becoming more and more important. It's getting more and more score in the whole certification system, and also as well as the whole building, the materials also they are required to have some certifications again, like environmental product declaration or any other material. Any other certification. For wood, there is different certification systems for other materials too. So this any material should be transparent in terms of the whole life cycle of that material for us to know what phases that material actually passed from production to disposal, and also to the recycling phase. In the university, I focus on, in my lecture, I focus mostly on life cycle assessment of buildings and of materials. I give a long-term, whole-term project to my students, and they are actually recognize and they notice a lot of things when they think about this whole life cycle. So it's very important. Yeah, this is just start. Maybe I can more add later. And
okay, thank you, Ahmet. It's a good point. You mentioned about the transparency. This point is very important. I would like to talk about a story. It's as a real story. And 3 years ago, a building was constructed in Izmir. The first material is timber. The second material is earth. What do you think about these two building materials? You talk about the concrete. Yes, it is high embodied energy. If we use the earth, and the carbon footprint is 1 unit energy. If we produce cement using earth, the carbon footprint is 10 units. Okay, 10 times bigger than earth if we use the cement. So this is important point, but sometimes if we use natural building materials, the buildings that was constructed by natural buildings materials is not sustainable and ecologically friendly. Why is that? A building constructed in Izmir uses timber and earth, but timber, the source of the timber is Germany. Mm-hmm. Raw material is coming from Germany, sent to Australian for timber processing. Okay, after that, the material comes from Australian to Turkey, Izmir. So, and the material is turning around the Earth. How many kilometers? More than 4,000, 5,000, okay? So, where is the source of the Earth? Eskişehir. The Earth material, kerpiç, comes from Eskişehir. So, when we go to the site, the user explain how sustainable this building is. We are using timber, we are using earth, but it is not sustainable. This is the transparency. We don't have the transparency, so we look at the buildings, we see timber, we see earth, but we don't know the story behind that building. So we should focus on this. And the transportation footprint is very important thing. Yes, the material could be sustainable, energy efficient, low embodied energy, but when look at the whole building process, life cycle assessment, that building is not sustainable. So what can we do? Maybe at the last phase, we can talk about what can we do. Mm-hmm. Okay? And I would like to explain my ideas at the later stage.
So from my point of view, that it is okay on the theory that we all know about life cycle assessment and we all know how it should be, but we also look at materials individually and we don't look at it as a whole system in a building, like how does it work, or okay, where does it come from, but also how does it affect the operational energy. Like we could be if we just keep our point or our perspective like limited with the material itself or material story by itself, then we are losing the whole point or how it will act or how it will perform in the building, within the built envelope. So like it would change, okay, I could use a lower carbon, lower embodied carbon material, it can have better performance, but then when I compare it with another, for example, double and triple glazing comparison, they all say it doesn't worth the extra pane of glass on the triple glaze. But when you do the actual calculations on the field, a little away from the theory, that it comes out that it changes my size of my radiators, it changes the use of energy that I use, the energy I require, and then when you look at the whole building cycle, or whole of it is life cycle, then it becomes more heavily embodied carbon becomes higher than the other option. So I think it is a challenging thing to look at it from only a single point, that the material itself is very risky and a little dangerous to compare materials like that. In addition, it is difficult to, for life cycle assessment, it is challenging to get the information from the architects or the contractor, etc. Especially in the countries that, like Turkey or like Pakistan, I know, because I worked in London as well. So the sustainability consultant gets into the project from the beginning, very beginning. Mm-hmm. Since they're starting to talk about the design, that we are in the project. So we have an opportunity to make it better or improve the design. But here, I can't even get the information for the concept design. I barely get a bill of materials at the end of the design. So all they want me to do is prove that, give them a number of embodied carbon. So there isn't any opportunity to improve in the design. Yeah, I believe. Mm-hmm. So I took the transparency from this perspective that we should be more multidisciplinary, maybe transdisciplinary work on this subject altogether.
Yeah. Yeah. Okay. Thank you all. Yeah, very interesting points that you point out. That it's not just if you have a really good building product, very pure product, then still you have no guarantee that you will have an excellent LCA because of transportation, because of the production side. Maybe, for an example, with cheap wool, the laundry of the fibers, or maybe the heat that you need for to create a certain product. And mostly the product phase and transportation phase are very important impacts in a LCA of a product. What we see in the Netherlands, you mentioned it, the comparison of materials using an LCA is indeed a very, very dangerous thing. In the Netherlands we use 17 impact categories at the moment, and these impact categories say something about the effect on water, sweet water, seawater, the effect on the earth, human toxicity. CO2 is of course one of the impacts. So there are quite a lot of aspects that you look at. What we do in the Netherlands is that we multiply the results with a certain factor, and that creates one number in euros that's supposed to be saying something about the impact of the material. But the problem with that is that if you have only one number, you don't know what the most important part, the most important impact is. Is there a problem on the water, or is it land use, or is it CO2? So you lose the transparency of what the real problem is of this product, and how can you improve this product. Which aspects do you need to improve? Are you going to make sure that you can get the ingredients from closer by? Or is a certain material, a certain ingredient, the problem itself? And should you try to change that? You have something to mention about that?
Just to add something. If you look from the building perspective, actually in Eastern countries like Turkey, the whole life energy consumption is getting high in the construction phase. Like 30% of the 20-30% of the whole energy consumption is coming from production. But when you go to Western countries like Northern Europe countries, then energy consumption for production phase is getting lower and lower, the embodied carbon energy. But the operational phase is getting higher in Western countries, which means actually even we do high carbon, high embodied carbon or embodied energy materials, if you use those materials correctly and in the building, and if you consider passive design and the whole design of the building according to the climate and environmental conditions, then we can decrease the whole energy consumption and carbon consumption. So it's important to look at the whole and to use the correct materials, actually.
Yes, I have to agree to that. Yeah, you have something to say about that?
Yeah, I really want to add the temporary and contemporary usages of the material and the building as well. Right now, the United Kingdom is arguing about not demolishing the buildings, but instead try to use them as long as possible, because the more you use the building and the material, the less in the equations and calculations the carbon emissions are getting. So in a way, making long-lasting buildings may affect the situation, but on the other hand, the temporary usages of some sort of buildings are, although it seems paradoxical, you are using natural building materials, and for example, I know an example, a concert hall, a temporary one. It is only done for a few weeks, and it is done by the cylindrical straw bales, and they just put the bales on top of each other and create an enclosure in the open site in the land that the straw is already produced, and then after a week or two they take them away. So long usages may be good, and short usages are also can be good in sense of carbon emissions. And I think as a Turkey we have a really serious problem. In 2050 the European countries are aiming to neutralize the carbon emissions in the construction industry. So in the existing situation, which cement, for example, when you are using lots of heat energy, so you are producing lots of carbon. So aluminium is worse than that, steel is worse than that. So at the end we need to turn back. I believe the natural building materials and the local materials can be the key points that we can achieve this carbon neutral aim in the near future. But in the existing construction industry and materials, I don't know how the solution can be. Thank you.
Okay. Yeah. What I wanted to mention is that an LCA is not a certificate. So it's not that if you have an LCA, your product is good. No, it just says something about the impact of the product. So even a product. To start with, an LCA was developed as a management tool. If you have an LCA, you have, like I mentioned before, you have insights on your product. Where are the major impacts and how can you improve that? So, like I said, getting the ingredients from close by, or maybe even changing an ingredient. So, what we see in the Netherlands, I mentioned it before, you put all the impact categories together and create one number. So it should be easier to compare one product to another, which you shouldn't do to start with. But okay, that is what happens. What we also see is that in that number, what we do in the Netherlands is different than how it's done in Europe and European regulations. So there are few countries that have slightly different methods added to the European way of calculating an LCA and communicating the results. And so in the Netherlands, we also add the Model D. Model D is actually a part that is outside the boundaries of the European LCA. It says something about reusing and gaining energy from burning up materials after it is used. So at the end of the life cycle, when you demolish the building, then you could harvest energy from burning up, for an example, wood or even plastics. Yes, it still happens. If you add that these benefits of the material to your LCA, you can create a better overall result. But if you think about it, you could see it more as a way of greenwashing to make your product appear better for the environment than it really is. Is that something you recognize? Is it something you see here in Turkey or maybe in the other countries where you are active?
Greenwashing in sustainability is very common, I think, and it is a really dangerous perspective from people. And we can also see it in terms like I use timber, etc., thinking that it will be more sustainable. But also, I think there should be more analysis on, especially in Turkey, for real performance of the materials, because then here we are only focused on the LEED certificates actually. So for getting the certificates, I even hear that they cover up, I mean, they made up the energy performance results according to the, different than the building.
If you talk about the certificates, do you mean
so
like
for LCA,
safety and so on? Or?
So, you know, for the LCA calculations in built environment, so they are changing, they are showing different products on the concept design, and then it changes on the application side. So I mean, there are some really difficult, different applications within the industry. So I think this is dangerous a little.
I think design people play an important role here. It's still at the very beginning phase in Turkey. The knowledge about materials, but I think it should be expanded, and it will expand in a very short time. When you design a building, for example, you use Revit design software, and in this software there are now cloud systems coming up. So cloud systems, when you design something, a building, we will immediately see the results of all materials, both per product and also as a whole in building. So, and you can accordingly design your building. It gives your results of the LCA results of that building. So, according to how much, how long you plan, you design for a building, like 50 years, for example. You immediately see the results in that program, in that software, in terms of cost, time. When you change something, a design in that building, or the materials, you will see the results, and then I think this will give an awareness to the design people, and also to the customers, also the owners. So they will actually make aware each other, which developing technologies when seeing the results. For example, it's very beginning phase, as I said. There is some databases, libraries, but they are not actively used. But if they integrate these libraries and databases integrated into the design softwares, then it will expand more, and I think much more healthy, let's say, or sustainable designs will be able to be made in the future. And another problem, I think, in Turkey is a very short time span of buildings, like 30, 40 years. Now, in average, we demolish a building in Turkey, a concrete building. However, in Western countries like Europe, maybe 100 years a building can stand. So that also is a very, very big parameter for life cycle assessment, life cycle of buildings. Yeah.
If you look at a building and you look at an LCA, you first of all have, of course, the impact of all the different materials used in the building, and that can indeed be the construction, of course, which is always an important impact, no matter what material you use. If it's wood or if it's concrete, it's still, when you talk about the volume, it's an important impact. Then it's, of course, all the different materials that you use for the windows, for the window frames, but also finishes. Are you using clay or paint or tiles for the floor, or maybe wooden boards? you have all these different parts. You also already mentioned, well, some of you already mentioned, like if you create a building that needs less insulation materials and create more of a passive house. So I don't know if the term passive house is known for all of you. In very short, it's to create a building that is so well insulated that you need so little or none insulation techniques to heat up the building and to keep the indoor climate comfortable for you. Usually ventilation is a part which is almost always there. So if you look at a building and you have used, well, certain materials, depending on the installations that you use, the installations that you use are often, that's what we see in the Netherlands, a very important part of the environmental impact of the building in total. So if you have less insulation materials, it's beneficial for the environmental impact of the building. But besides that, you also have the use phase, and the use phase is one part is it's the energy use of the materials, of the lighting, for the heating, for the electricity, all these different parts. But also, of course, the end of life stage for this installation, and also the maintenance of these installations, filters, different parts that need to be changed after a certain amount of years. How do you look at that part? Because that's a very important part when you look at LCAs and buildings. And I know that all of you have something to say about that because you mentioned it.
Just a quick information on passive house, so like people can imagine better. Like a normal building energy consumption is about 80, let's say, low energy building in Turkey, classified as low energy building, is 80 kilowatt hour per square meter, but in passive house it is less than 15. So it is a highly energy efficient envelope, but it is again has some problems. I mean, we can make it really high in terms of very high embodied carbon by selecting wrong materials maybe, or like dangerous materials, or we can make it really low embodied carbon while we are designing it. So, but it is difficult to here because we import all the ventilation system to Turkey, all the insulation, etc. If we want to use specific materials. But again, if we don't do it, then what is next? I mean, some councils in England, they are saying minimum, they are putting passive house as a minimum, but it is because like as soon as we minimize the energy consumption, then we will really and we will also focus on embodied energy. Then we can start talking about net zero buildings or low carbon buildings. So I mean, we should agree on that point, that minimizing our energy requirement, and also we should focus on using low embodied energy carbon materials within our buildings. But again, like looking at the system in a building, like we could choose A and B options. So when we just look at the material by itself, like A is high embodied carbon, but when I use it in the building with all of the system that it needs to carry that component, then it makes it as a whole of the wall system, for example, it makes it more, in terms of embodied carbon, it makes it higher. So from case to case, I could choose maybe on the comparison, a little higher embodied carbon material, but on the application on the building side, on the construction side, I could find a better way to make it as a whole a low embodied carbon building.
Mm-hmm.
I think the Turkey's first passive house certificated building was done in Gaziantep, and passive house is a package. You just take it and try to have the standards more or less where you apply it in everywhere of the earth. So that's a problematic issue. So the Gaziantep's passive house is not working efficiently. So you could have designed it better and build it, because that huge amount of insulation is not necessary for the climate of the Gaziantep. So when the context changes, the solutions should also change. The problem is we are, searching for the ultimate material, ultimate solution, and ultimate correct answer for each and different cases. So this is not working. This is not architecture. This is not engineering. So that's why the carbon emissions are booming, especially if those thick insulation materials is the petroleum-based insulation materials. Then the problem is increasing. You are targeting to make a energy efficient building, green building, sustainable building, whatever it is, because these concepts are also different. So you can make a sustainable building, but it cannot be energy efficient maybe, or you can have zero carbon building or carbon neutral building, but yet the energy efficiency may not be high, or what is energy efficiency? So the building in the 20th century can be an energy efficient building, but right now it is becoming an all ordinary standard. So that standard is also developing day by day. Thank you.
Mm-hmm. And just to add, yes, it's very important actually, thank you. We are talking about sustainable building, sustainability, life cycle assessment, etc. But actually, humans should be sustainable first, because there is statistics about the energy consumption. 30% of whole energy consumption in the world is depending actually on human behaviors, daily consumption patterns. So, okay, we are doing smart buildings, sustainable buildings, but we should be smart first. Just to give an example, in average, 25 degrees indoor environment temperature in Turkey in winter. If we decrease this just 1 degrees, 24 degrees, then we actually save a couple of $1 billion in a year in Turkey just from this temperature. But actually, we don't need that temperature in the winters. In winter, you know, it's like 19, 20, 21 degrees is good for our health. So we are actually excessively using this energy. This is only for heating. There is also other examples. So if we should be smart, because there is for the energy consumption, you know, there is a pyramid. So there is also first reduction, then efficiency, and then renewable energies come in. This is just a complementary thing, but first we need to reduce first for energy, for water, for also in daily shopping, anything. I think this is also a good, very big parameter in sustainability and also life cycle.
Most of them you mentioned, but I'd like to highlight a point. Architects design the buildings with general data, global data. For instance, I'd like to give an example, a general data. If we use more insulation in buildings, it is more energy efficient, and so it is better. But in reality, in some climates, this doesn't work. So, and we need more climate specific, for instance, Izmir specific, Mediterranean specific, and the solutions and research. And when look at the carbon footprint or environmental impact of the whole buildings. So if we have, for instance, if we know what is the best possible insulation thickness in Mediterranean climate, if we optimize the results considering both environmental impact, embodied energy, and also operational energy use. So we should use this and the optimized knowledge when constructing our buildings. This is an important point for the architects.
Okay, well, thank you very much. Talked about a lot of things. Just to short summon, it's if you look at LCAs, you have the products and you have the buildings in total. So also look at it in such a way. If you use certain materials, how will they all add up? What will the building do when you use it? What kind of installations do you use, or maybe not use them? And how will you work with the materials at the end of the life phase? Well, thank you. You've added really interesting points to this conversation about this topic. I hope you all have a little bit more of an idea about what can you focus on with LCAs for products and for buildings, and hopefully this helps to create more insight here in this beautiful country. Thank you all for your attention.